Today, today we will be discussing the various restructured model which will be used for generally for calculation of cost and other related. So three major models are used in the power system. One is pool-co model, then second is your bilateral contract model, and third is hybrid model. So in pool-co model, it is a centralized marketplace that clear the market for buyers and sellers, where electronic power sellers, buyers will submit the bid and the price into the pool for the amount of energy that they are willing to sell or buy. So it is a centralized marketplace for buyers and sellers. They will place bid and price into the pool. Then the main characteristic of this model is that the establishment of the independently owned wholesale power pool served by interconnected transmission system. So independently own wholesale power pool that is independent to the transmission lines and distribution lines, and they will not be participating in the wholesale power pool. This pool become a centralized clearing market for trading electricity, which would implement competition by forcing distribution utilities to purchase their power from the pool co instead of trading with the generating companies. So distribution utilities will purchase power from the pool co and sell power at the market clearing price. These companies will sell at the market clearing price, MCP, defined by the pool co, instead of a price which is based on the generating cost, as in the case of vertical integrated monopoly. So as in the case of vertical integrated monopoly, the power is decided by the single company or regulating authorities, but in case of pool cos, the distribution utilities will purchase the power from pool cos and sell power at market clearing price. Final price may increase than MCP, that is market clearing price, for account for charges of auxiliary services and ISO cost. Submitted bid to injected power into and out of the pool. So the pool co does not own any generation or transmission companies and centrally dispatched at generating units within the service judiciary of the pool. In the pool co, sellers and buyers will submit their bid to injected power into and out of the pool. Sellers compete for the right to inject power into the grid, not for specific customers. If a power provider bids too high, it may not be able to sell the power. On the other hand, if the buyers compete for buying power and if their bid are too low, they may not getting any power. In this market, low cost generation would essentially be rewarded. Power pool would implement the economical dispatch. In the pool co, sellers and buyers will submit their bid to the injected power into and out of the pool. Sellers will compete for the right of injected power into the grid, not for the specific customers. In this market, low cost generators would essentially be rewarded. Power pool would implement the economical dispatch and produce a single price for electricity, giving practical clearing signal for the consumption and investment decisions. So if we are talking about poolco, so it will be, we have generating companies, Gencos, then we have transmission lines, then we have discoms or bulk power buyers, and then we have consumers. So we have this signals which will be flowing, and we have powers which will be flowing. So single line is sending the signal, and double line, double arrows are sending for so we have Gencos, then we have transmission lines, then we have discoms or bulk buyers, and then we have consumers. So the signal will be flowing from this to this, and with double arrow we are showing that energy will be flowing from this side to this side. So this is a simple power pool model, and the modified power pool model is this, in which we have Gencos, and then we have transmission lines, then we have discoms or retailers, and then we have consumers. Then discoms will be coordinating with the retailers, and we can, energy will be flowing from discom to transmission lines, sorry, Gencos to transmission lines, and then discoms, and then consumers. And retailers are only intermediate. They will be purchasing the power and selling the power with the help of discoms. So the signal flow is like shown by single arrow, and energy flow will be shown in the double arrow. That is, Genco will be sending to transmission lines, transmission will be sending to discoms, and then discom will be sending to consumers. Retailers are not practical entity. They will be not be getting any power, and there will be no power which will be flowing with the help of retailers. They will be only working as the intermediate between the two systems. So then we have a bilateral contract, that is direct access model, in which we have two characteristics. In this, the ISO role is limited, and buyers and sellers could negotiate directly into the marketplace. In the power pool model, there is no provision of negotiations, but in bilateral contract model, their buyers and sellers could negotiate directly into the marketplace. They permits direct contract between the consumers and generators without entering into the marketplace. So in this, without going through the marketplace, the companies can directly purchase power from the generators without entering into the marketplace. The wholesale suppliers would pay transmission charges to transmission companies and distribution charges to distribution companies. So in this, the wholesale suppliers would pay the transmission charges, that is, they will be using for the transmission of the power, and this model is represented by this. We have GENCOs, then we have scheduling coordinators and transmission operators or transmission owners. The scheduling coordinators will be only scheduling the signal and scheduling the generating stations, and then with the help of transmission line discoms, the consumer will be getting the power. So power flow is from GENCOs to transmission, then discoms to consumers, as in the previous case. But in this case, we have scheduling coordinators which will be working in coordination with ISO companies, and then we have retailers which will be working in coordination with discoms, and with the help of all these, it will be coordinating the complete system. So in this, the consumers has the authority that they can directly purchase the power from GENCOs companies without going into the marketplace. So in this, the distribution company may function as an aggregator for a large number of retail consumers. Two contracted parties would agree on contract terms, and generation providers would inform the ISO for dispatch schedule. So when we have contracted, there is a contract between generating stations and the consumers, then they will be sending a signal to the ISO for dispatch schedule according to the agreement, and the ISO will make sure that sufficient resources are available to finalize the transactions and maintain the system reliability. So the ISO will be coordinating that the power will be dispatched as scheduled and there will be no delay in the system. Then we have third is that hybrid model, which is different from the power pool model, as it will utilize the PX, that is power exchange, is not obligatory, and customers are allowed to sign bilateral contract and choose supplier from the pool. So in this hybrid model, the advantage associated with power pool and advantage associated with bilateral system has been incorporated. So then we have some terms which are generally used for the system. So we must understand these terms. So first, the main term which will be coming again and again in the system is market clearing price, that is MCP. So MCP is the cost at which the PX accepts supply and demand bid to determine the MCP for each of the 24 periods of a day. That means power exchange will be accepting the supply and demand bid. That means from generating companies, it will be get a bid, and then it will be getting a bid from the demand. That means discom companies, and then it will be deciding the MCP. Then MCP will be decided that computer will aggregate all valid supply bids and demand bids, draw the aggregated demand bid curve and aggregated supply curve. So it will be drawing a demand curve and it will be also drawing a supply curve on the basis of various bids submitted by the system. And then MCP are determined at the interaction of the two curves and all the valid and all the trades are executed at the MCP. So we have two curves. One will be like this, that is for generation. Then we have second curve that will be like this, that will be for demand. And MCP will be decided at this point, interaction point of these two curves. So MCP, minimum clearing price, will be the price at which both the demand curve and supply curve will meet. That will be termed as the MCP, because before this meeting point, generation cost may be lower and the demand cost may be higher, and after this point, demand cost will be maybe lower and the generation cost may be higher. So that's why we are getting a intermediate point in which all the bidders and of generation and distribution will be considered. So MCP is the balance price at the market equilibrium for the aggregated supply and demand graph. Then the generators are encouraged to bid according to their operating cost. So in this system, the generators are encouraged to bid according to their operating cost. Bidding higher would cause units to run less frequently or not run at all, because if they are bidding higher price, then no one want to purchase that power. That means in the low demand scenario, there will be no buyers for the generating companies. And if they are submitting very low bid, then it may be possible that they will be having a losses in their system. So these are the decided on the basis of MCPs. So we have a day ahead or overhead market. As its name suggests, day ahead is for a complete day and overhead is a hourly marketplace. So in the day ahead, sellers bid a schedule of supply at various prices. Buyers bid a schedule of demand at various prices. Then MCP is determined for each hour. Then seller specify the resources for the sold power and buyers specify the delivery point for the purchase power. And PX will schedule the supply and demand with the help of ISO. So this is how we will be bidding in the market. Sellers will be bidding for selling their power. Bidders will be bidding for purchasing the powers. And on the basis of MCP, the sellers will be then specify the resources they will be using for selling the power, and the buyers will be specifying the delivery point where they want that purchased power to be delivered. And the PX will be schedule the supply demand with the help of ISO, that is independent service operators. So we can have a single bid system and we can have a double bid system. So as the name suggests, single side auction, that means single side bid, means we have only supply curve for elasticity, and there will be no demand elasticity. Elasticity means on the basis of demand, the supply cost or the distribution cost can be lowered or increased, because in that case the power which will be generated will be more and the demand is low, and at that time we require that the system cost to be minimum. And if there is a less generation and high demand, then the generating companies will be taking higher price for selling their power. So in the single side market, the supply curve have elasticity. That means we have different price curve for the different scenarios, but the demand remain inelastic. That means demand will not change. So an inelastic market or single side auction market does not provide sufficient signal or incentives to a consumer to adjust the demand in response to the price, i.e. the consumers does not have any motivation to adjust its demand for electric energy to adapt to market conditions. Here supply curve show elasticity, i.e. there are different price offered for energy for each of the supply curve, while the demand remain inelastic, i.e. demand for energy is the same regardless of the price of energy. That means demand will be remaining same instead of there will be a price difference in overly schedule of the system. So these are single side auction market, and in double side auction market, that is elastic market, both the supply and demand will have elasticity, that there are different price offered for energy for each of the supply and demand. So in double side market, we have elasticity on demand side, and also we have elasticity on supply side. That means the price at which the generating companies will be distributing power will be different according to the demand, and also the demand side, that means Discom will be purchasing the power and they will be adjusting their power so that they will be getting energy average cost at low. So these are the simple single side bidding market and double side bidding markets. So now we have different costs which are associated with the companies. So we have standard cost, that is in vertical integrated monopolies, the utilities are used to cover their cost of doing business in rates charged to the customers. Cost include operating cost and investment capital cost, where utilities cover these costs and considerable return on their capital through rates imposed on the consumers. But when restructuring is proposed to open market competition, and due to the fact that market-based prices are uncertain and sometimes less than vertical integrated rates. Financial obligations of vertical integrated utilities may become unrecoverable in a competitive market, and the level of revenues earned by a utility may no longer be adequate to cover its cost. If the market price is lower than vertical integrated rates, as may expect, utilities could be faced with investments that are unrecoverable in the competitive market. Standard cost is the difference between costs that are expected to be recovered under the rate regulation and those recoverable in the competitive market. So then we have transmission line system, because when we are talking about power system, we are talking for generations and we are talking for distributions, and we are very lessly talking about transmission system, but it is the major part of the system because it will be utilized for transmitting the power from the generating stations to the consumers. So the transmission line is the key issue of the competition, and the major cost will be decided on the basis that the system will meet traditional revenue requirements of the transmission owners, and they reflect the comparability, i.e., a transmission owner could charge itself on the same basis that it could charge other for the same service. That means if the transmission lines owners are bidding for the supplying of power, that means they want to be a retailer, the cost which are they will be charging to themselves must be same as the charging by the other companies. And then the system must promote economical efficiency of the system. Then cost must promote fairness of the system. Cost must be practical, and even through transmission costs are small as compared to the power production expenses and represents a small percentage of major investments on utilities like operating expenses. Transmission system is the most important key to competition because it would provide price signal that can create efficiencies in the power generation models. So the cost which we are deciding must be such that the transmission costs are very small as compared to the power production expenses and represents a small percentage of major investment on utilities operating expenses. So the transmission prices are generally decided on the two methods. First is contract path method and second is MW mile method. So as the name suggests, contract path method, that means the cost will be decided on the basis of the path which will be used for supplying the power. That means we have predefined path in which the power will be transmitted to the users. So it has been used between the transacted parties to price transmission where power flow are assumed to flow over a predefined path. So we are assuming that power will be flowing through a predefined path, and we will be charging on the basis of predefined path. Despite its easiness, this technique are claimed to be a bad implementation of true transmission pricing, as power flow would be, as power can be flowing or can be taking any path instead of taking a predefined path, because power flow is not in our hand. It will be decided on the basis of system parameters. So as we are using a predefined path in this, it is not generally possible that it will be using the same path. So it is a bad implementation of true transmission pricing. The electrons could flow in a network over parallel paths owned by several different utilities. They may not be on a contract path, because there are many alternate paths which are available, and electrons can flow in a network over a parallel path where we don't have contact, and it will deviate from the predefined path. And then the parallel path flow referred to the unscheduled transmission flows that occurs on adjoining transmission lines when power is transferred in an interconnected electrical system. As a result, the transmission owners may not be compensated for the actual use of their facilities. And added to parallel path, the pancaking of transmission rates is another shortcoming of this model. Pancaking is when contracted path crosses a boundary predefined transmission ownership. Additional transmission charges would be added to a transactions, which in turn might increase the price of the transactions. So it is an inefficient methods of calculation of transmission price. So instead of using contracted path methods, now we are using MW mile method. So many ISOs are using MW mile approach to price the transmission lines, as it is defining MW mile. That means the MW mile rate is basically based on the distance between transacted parties from the generating source to the load, and flow in each line resulted from the transaction. So the MW mile rate are basically decided on the basis of distance between the generating stations and distribution stations, and it will be not be affected by which path this will be used. This approach takes into account parallel power flows and eliminate the previous problem that transmission owners were not compensated for their facilities. This approach does not give credit for counter flows on transmission lines. This method is complicated because every change in the transmission line or transmission equipments require a recalculation of flow and charges in all the lines. So if there are any change in the power system, then we require that the complete system will be rearranged and power will be recalculated for the complete system. So these are the two methods which are used for the calculation of transmission line cost, and that is incorporated in the system cost. So these are the various costs which are decided on the basis of the various requirement of the system. So this is all about restructured power system. So if you have any doubt, you can ask, because today our syllabus is complete, and you can send me if you have any doubt on a WhatsApp, then we can have a